Let's go slowly code 846 hand of streets. For this question, it gives us a integer array hand and also a integer number group size. It asks whether this kind of integer array hand can be divided into several groups, and each group has a group size of element. And for each group, those kind of numbers are streets, that is, they are consecutive numbers. For example, example one, right? We can divide this kind of group into three subgroups. This hand into three groups, and each group have three number, and these number are consecutive numbers, so it will return true. So what we think about is that we can to count those kind of number with its frequencies, right? And for example, this one appears once, right? Two appears twice, and three appears twice. Four appears once, right? And 6, 7, 8 appear once, right? Then what we are going to do is that we from the smallest key, and we use a map to have this, right? We smallest key, we remove this, and then for this key, to key plus one, right? To key plus group size. Actually, plus group size minus one, right? Until we all, and for example, this is we get this number, but for example, this key has a value constantly be, right? So in the map, we all set this value to be to divide to subtract v, right? And for example, this is one, right? And we divide subtract by one, right? So if this subtract by one is 0, right, then we can remove this from the map. And doing one round, right? So that is group size. And the next round, we find us still looking for the smallest key. Now the value is 1, right? So this 3, we need to remove 1. So it will become 0, 0, 0. So we remove this from the map, right? And then we look at the smallest key is this, right? And this is 1. We will remove 1. This becomes 0, 0, 0, right? So this will be removed to the map. So if in the end the map will be empty, right? We will return true. And when we update, if there is any key which have the value to be a negative number, right? Then we'll return false. We want the key every time we find the smallest one. We can use a tree map to do this. So let's begin to write code for this, right? We're going to use a tree map integer map equals new tree map, and for int hard, right? In hand, this will have map merge hard one integer sum, right? Then what we do is that while this kind of map is not empty, and we are going to have int key equals the first map dot first key, right? First key. And then let's have these counts, right? For this first key equals map get get this way, right? So for int I equals to 0, I smaller than group size I plus plus. What we're going to do is that we're going to try to update this kind of map merge p plus I, right? And let's subtract this as a v, right? In the integer sum, right? Doing like this, we don't need to worry about whether the key exists or not, right? If it does not exist, it will just insert a negative value. So that means that we can do the validation here, right? If we map it k plus I, if this is smaller than 0, then means we don't, for this number, we don't have enough card, right? Return false. And I will say if map it k plus I equals 0, right? We're going to remove map, remove k plus I, right? And then in the end, return true. For this question, if we change this to hash map, right? And what we need is that for every key, we need to find its smallest one. Doing like this one, the time complexity will not be improved. So the change, you see, hash, if we change to hash map, I think that code change will be simpler, right? But every time we need to find the smallest one. For the smallest key, of course we can write if map contains key, right? Contains key num -1, right? We should continue. And why this is not we do this, right? For example, we want to find the smallest key. If we let's set key equals -1, right? For enter key in map.key set, right? If map contains key, doesn't contain. If map contains key -1, right? We should continue. And then we set k equals key, right? Doing this one not improve the performance. The reason is that even this part, right, we change a log to a linear, but this one we'll use a for loop to search the initial key. So let's run the result. I think this will be slower than you'll see it take a 700 and some those kind of time, right? So for this one, we use tree map will be beta time complexity. This is different than the question of LeetCode 128. The longest consecutive subsequence, right? So for that one, we can use set, and for every number, if it contains numbers -1, we continue. And for every one number, we find the smallest one, and from the smallest number to get its consecutive sequence. This one will still be linear operation because every number will be count at most twice. But for us, this kind of problem, it's not linear, right? Because it's possible, we can compose, for example, the smallest key has number 1, right? Then, for example, 2 has 2, right? So when we look at this kind of map key set, for example, this may be a bigger number. For example, this is k 1000, 1000. It appears 1000 times. But when we find the smallest, maybe it is still from the 1, right? And the next time, it will not get rid of 1000. So doing like this, for this question, we use hash map will not improve the time complexity, right? So let's use the tree map. The tree map, if there are, for example, there are m keys, right? So this kind of tree map that is a log operation, right? So this is insert that is n log n operation, right? And if there are m keys, and for those m keys, right, we are doing how many operations, that is n divided by averaged by the group size, right? While do those kind of iterations while loops, and they multiply by the log map size. That will be the time complexity. Let's convert this, change this to Python code, right? Let's have a count equals counter and okay, and we're going to have a map, right? So map, let's call ordered count equals order the big and sorted also looking sorted count items. Yeah. Yeah. So the same thing, while ordered count will have key, the first key, right? First key equals next iter an order count, right? And the value equals ordered count gate key. And then what we do is the for I in range group size, we're going to have a let's have a current key, right? Current key equals I plus k, k plus I. Okay. So if ordered count, if current key not in, right? If doesn't contains return false. Or ordered count ck smaller than v, right? Then return false. Then we'll have ordered count ck should minus equal to v, right? And if ordered count ck equals to 0, we should remove it. Delete ordered count ck, right? Current key. And in the end, we return true. There's no to be count. Ordered count. Okay. Ordered